Welcome students. Welcome to the next session of chemistry class. Last few classes you had studied just introduction to chemistry. In this session, from now on, you are going to study about atomic structure of an atom. It is an important chapter in your first PU syllabus. So I request all of you to listen to this lesson carefully. Make important points which appears on each slide. Keep it as a notes for you. Later on, during the test time and exam time, it will be useful for you for revision. Okay, sit back and watch this video carefully. Okay, structure of atom. Introduction to structure of atom. The pure substance that cannot be further divided is called elements. The pure substances that cannot be further divided is called elements. The smallest particle of an element which take part in chemical reaction is called an atom. The smallest particle of an element which takes part in chemical reaction is called atom. Pure substance that cannot be further divided is called elements. The smallest particle of an element which take part in chemical reaction is called atom. Now the word atom has been derived from Greek word atomio, which means uncuttable. So the word atom is derived from the Greek word atomio, which means uncuttable. In 1808, Dalton stated that an atom is the smallest particle of a substance which cannot be further divided. Later, experiments have shown that atom is not the smallest particle and it can be further divided to get smaller particles like protons, neutrons and electrons, which are called fundamental particles or subatomic particles. So what do we conclude? Though atom is the smallest particle of a substance, atom can also be further divided to give small particles like protons, neutrons and electrons, which are together called subatomic particles. Next, let's study the discovery of electron. How exactly we got to know that atoms can be further divided and it has made up of particles like protons, electrons and neutrons. Electrons was discovered by J.J. Thomson as a result of study of cathode rays. So the first discovery made by Thomson was electrons, which was due to the cathode ray experiment. When a high voltage of about 10,000 volts is applied to a gas at low pressure taken in a discharge tube, invisible rays originating from cathode are produced. Now this is the experimental setup. What are the experimental setup you are going to take when high voltage of about 10,000 volts is applied to a gas at low pressure taken in a discharge tube? Invisible rays originating from cathode are produced. The invisible rays originated from cathode are called cathode rays. So the rays originating from cathode are called cathode rays. Thomson showed that cathode rays consist of negatively charged particle since the rays are migrated towards anode. So after conducting the experiment, this is called the discharge tube experiment. Okay, Thomson found an invisible rays originating from cathode. and those rays which is originating from cathode is moving towards anode. So what he concludes, Thomson showed that cathode rays consists of negatively charged particle since the rays are migrated towards anode. The negatively charged particles are named as electrons. The negatively charged particles are named as electrons. Okay, so this is how electrons were discovered. So who discovered electrons? It is J.J. Thomson. And this is the description you got to know in the previous slide. You have a discharge tube here. Can you see a discharge tube with two electrodes? You are applying a high potential. Can you see here? High voltage generator. You're going to apply high potential between these two electrodes, cathode and anode. Okay. Then you are reducing the pressure of the gas. You're going to take the gas here. You're going to take a gas between the two electrodes where it is at very low pressure. Air at very low pressure is taken here. So how do I reduce pressure here? I'll connect it to a vacuum pump. So I keep on reducing the pressure. Okay, then very important is this potential source. You are connecting this two electrode to a very high potential source. Then what do you observe? Potential is high, pressure is low. You can see the rays originating from cathode. Okay, now these rays which are originating from cathode is slowly moving towards anode. So what Thomson said is those showed that cathode rays consist of negatively charged particle since the rays are migrated towards anode. Since the rays are, can you see here? The rays are moving towards anode. Since it is moving towards anode, where anode is positive, cathode rays are moving towards anode. Anode is positive. Therefore, cathode ray consists of negatively charged particle called electrons. So, this is the first discovery. It is discovery of electrons. Okay. Now, next. What are the properties of cathode rays? Very, very important. What are the properties of cathode rays? Cathode rays move in a straight line. Cathode rays move in a straight line. They are made up of negatively charged particle. Second point is they are made up of negatively charged particle. They are deflected towards anode in an electric field. So, three important points about cathode ray. Cathode rays moves in a straight line. They are made up of negatively charged particles. They are deflected towards anode in an electric field. You can see in this diagram, you have cathode here. You can see the ray originating from cathode. You have an electric field here. This is the positive pole and this is the negative pole of the electric field. Cathode ray is moving towards the positive pole. They are deflected towards anode in an electric field. So, you have introduced the electric field here, okay, and the ray is getting deflected towards anode. So, these are the three important points about cathode rays. Next, properties of electrons. What are the important properties of electrons? When we say important properties of electron, we'll try and study the physical properties of electron. First one, mass of electron is 9.11 into 10 power minus 31 kg. Charge of an electron is minus 1.602 into 10 power minus 19 coulomb. Last point, electron is represented as small e minus. So these three important physical quantities of electron, that is mass of an electron, charge of an electron and representation of electron. You have to know, please make a note. You need not by heart these values. So wherever you need to use these values, wherever you come across these values for, that is mass of electron and charge of electron, if you need to use in a problem, definitely it will be given in the problem. So you need not by heart these values, but you should know You should know what is the mass of an electron could be, what is the charge of an electron could be. Just for the information's sake, you need to know, but please don't by heart. Definitely, if it is required in the problem, it will be given in the problem itself. So, these are the properties of electron. Three important properties of electron. So, till now, we have understood the discovery of electron. We understood properties of cathode rays, and we also understood properties of electrons. Next, discovery of protons. Protons was discovered by Goldstein as a result of study of anode rays. For electron, we studied cathode rays. For protons, we need to study anode rays. When perforated cathode is used in the discharge tube experiment, a stream of positively charged particles were found behind cathode. So what we have done here, the same discharge tube experiment, what you did for discovery of electron, same discharge tube experiment is conducted, but instead of normal cathode, a perforated cathode is used. What do you mean by perforated cathode? Perforation means holes. The cathode, if you take a strip of cathode metal, the metal will have lot of holes in it. So when perforated cathode is used in the discharge tube experiment, a stream of positively charged particles were found behind cathode. The stream of positively charged particle is called as anode ray. Anode ray are also called canal rays. We'll understand why anode ray is also called as canal rays little later. So stream of positively charged particle is called anode rays. Anode rays are also called canal rays. Anode rays travel in a direction opposite to the direction of cathode rays. So what will be the movement of anode ray? Movement of anode ray is opposite to the movement of cathode ray. When hydrogen gas is taken in a discharge tube experiment, lightest positively charged particles are obtained, which are called as protons. When hydrogen gas is taken in the discharge tube experiment, lightest positively charged particles are obtained, which are called as protons. So that is how a proton was discovered. Okay. We'll come to the diagram now. If you remember, it's the same setup where you have two electrodes here. You connect it to vacuum pump and you connect it, if you see here, positive and negative, it is connected to the high potential source. And keep on reducing the pressure of the gas here. Increase the potential, high potential, go to high potential range. We observe, if you can see, we have rays originating from anode. But can you see the perforated cathode here? Can you see the holes here? Cathode ray, which has holes, is called as perforated cathode. These anode rays passes through the holes. That is why it is called as canal rays. Canal means it is through a narrow space. It is moving through a narrow space. It is moving through holes. Hence it is called as canal rays. So in this experiment, what do you observe? You observe the ray behind the cathode. So the rays which are present behind the cathode, which is called as positive rays. Okay, it is anode rays. The rays behind the cathode is called as anode rays. But if you can see, observe the two experimental setup, experiment for cathode ray and experiment for anode ray, it's one and the same. With a small change, you have a perforated cathode here, right? Okay, what are the properties of anode rays? Now let us study the properties of anode rays. Anode rays move in a straight line. They are made up of positively charged particles. They are deflected towards cathode in an electric field. Can you see the 3 points here? Same 3 points we had for cathode also. Cathode rays move in a straight line. Anode rays move in a straight line. Cathode rays are made up of negatively charged particles. Anode rays are made up of positively charged particles. Cathode ray deflects towards anode. Anode rays are deflected towards cathode in an electric field. If you can see the same diagram here, you have cathode, you have anode, you are introducing an electric field here. Can you see a positive field and negative field? You have connected to a high potential source. You can see the rays originating from anode. Can you see the rays here originating from anode? It is getting deflected towards cathode. So that is the property of anode rays. Next. Then what are protons? So the particles which are present in anode rays are called protons. So what are the properties of protons? Like we studied properties of electrons, we need to study properties of protons also. First property, mass of the proton. Mass of the proton is 1.672 into 10 power minus 27 kg. Charge of a proton is plus 1.602 into 10 power minus 19 coulomb. See here, charge of proton and charge of electron is the same. The value is the same. What is the value? 1.602 into 10 power minus 19. But the charge for proton is positive, the charge for electron is negative. So that is the difference between charge of proton and charge of electron. Then how do we represent proton? Proton is represented as P superscript 1 and subscript 1 or H plus. Best way to represent a proton is H plus. So these are the three important properties of protons. Please students make a note of it in your notebook. Okay, next. We finished with discovery of electrons. We finished with discovery of protons. Now coming to discovery of neutrons. Neutrons were discovered by James Chadwick. How did he discover? When beryllium sample is bombarded with a stream of alpha particles, radiations containing neutral particles are emitted. What was the experiment? When beryllium sample is bombarded with a stream of alpha particles, radiations containing neutral particles are emitted. These neutral particles were named as neutrons. Okay, so how was neutron obtained? When beryllium was bombarded with alpha particles. Now what is an alpha particle? You can make a note or we'll learn it later in physics, nuclear physics. Alpha particle is doubly ionized helium nuclei. What is alpha particle? Doubly ionized helium nuclei. If you are not able to understand here, never mind. You'll study this in the chapter of nuclear physics. Okay, so how did we obtain neutrons now? Beryllium was bombarded with alpha rays. Radiation containing neutral particles were obtained, and the neutral particle is called as neutron. So who discovered neutron? James Chadwick discovered neutrons. Okay, so now we are done with three particles. We understood discovery of electrons. We understood discovery of protons. We are finished with discovery of neutrons also. Okay, so three particles which are called as subatomic particles or fundamental particles of atom. We finished with, we understood all the three. Next, what are the properties of neutrons? Again, we have to consider the mass of the neutron. Mass of the neutron is 1.675 into 10 power minus 27 kg. Charge of a neutron is 0. It doesn't have any charge. Then how do you represent a neutron? N10. Okay, so mass, charge and representation. So if you just see three properties, that is properties of electrons, properties of protons and properties of neutrons. What did we study in that property? These 3 points. What are the 3 points we studied? Mass of the neutrons, charge of the neutrons and representation. Same way for both protons and electrons also. Again, I'll remind you, you need not by heart these values. Of course, charge of the neutron is 0 and representation you need to know, but mass of the electron, mass of the proton, then charge of the electron, charge of the proton, values you need not by heart. but get to know. Okay. Next. Very, very important part we need to understand now. We finished with the fundamental particles. We understood protons, we understood electrons, we understood neutrons. We got to know the discovery of those three particles. Now the next term, actually, I'll call this as a term. The next term you need to know in the chapter of structure of atom is this: atomic number. What is atomic number? The number of protons present in the nucleus of an atom is called atomic number. Number of protons present in the nucleus of an atom is called atomic number. In an atom, the number of protons is exactly equal to number of electrons. Proton number and electron number is the same. Therefore, atomic number is equal to number of electrons. Atomic number is equal to number of electrons. Atomic number of an element is always a whole number. It's always a whole number. Got to say, it is not a fraction. Atomic number of an element is always a whole number. Then, no two elements have same atomic number. Suppose if I take hydrogen and if I take helium, atomic number of hydrogen is 1, atomic number of helium is 2. So, no two elements have same atomic number. Atomic number is represented by capital Z. How do you represent atomic number? It is represented by capital Z. Okay, so we got to know the new term atomic number. So what is atomic number? It is the number of protons present in the nucleus of an atom, but number of protons is equal to number of electrons. Therefore, atomic number of an element is equal to the number of electrons present in the element. Okay, so no two elements will have the same atomic number, and we represent atomic number using capital Z. Okay, next, mass number. Next term is mass number. Now we'll see what is mass number. The nucleus of an atom contains protons and neutrons, which is collectively called nucleons. What are nucleons? In the nucleus of an atom, the protons and neutrons present. The number of protons and the number of neutrons present gives you that is the protons and the neutrons present is collectively called nucleons. The total number of protons and neutrons present in the nucleus of an atom is called mass number. So, number of proton plus number of neutrons is added. It is called as the mass number. Mass number is represented by capital A. Mass number is represented by capital A. A is equal to P plus N. What is A? A is mass number. P is number of protons. N is number of neutrons, where P is number of protons, N is number of neutrons. Put P is equal to Z, A is equal to Z plus N. That is, mass number is equal to, what is Z? Number of electrons. So, A is equal to number of electrons plus number of neutrons. Okay. So, finally, mass number, what we understand? Mass number is the number of electrons plus number of neutrons is what the mass number is. Okay, so we understood two important terms. One is atomic number, where atomic number means it is the number of electrons present in an atom. Then mass number is the number of electrons plus number of neutrons, because we know that number of electrons is equal to number of protons. Therefore, mass number is equal to number of electrons plus number of neutrons. Okay, so this is how we understand the two important terms, atomic number and mass number. Now students, this is an important point which you need to know. There are 3 assignment questions. You have to take down these assignment questions in your book. Take a 200 pages notebook, one and a 100 pages notebook. 200 pages notebook is for you to take down the notes. The entire notes you're going to maintain in that 200 pages notebook. It could be ruled or unruled, left to your convenience. But assignments, write it in a separate book which is of 100 pages. Okay, and write it these questions. What is the first question? Give the properties of cathode rays. Second one, name a particle which has no charge. Third one, define atomic number and mass number. Clear, students? Please take down these 3 questions and maintain this, writing this in a separate 100 pages notebook and make it as assignment book. Okay, 200 pages book will be your notes book where you're going to write the notes for this chapter in that book and maintain that. So 2 separate books you're going to maintain for chemistry. Okay, students, with this I end with the first session. Okay, in the next session we'll understand more about structure of atoms. Until then, bye. See you in the next session. Thank you.